This Openstax Finance Chapter 13 regarding stats examines the applications of this in the finance industry. It's used extensively in finance, with applications ranging from consumer concerns such as credit scores, retirement planning, and insurance, as well as business concerns like stock market volatility and predicting inflation. Business managers employ a wide range of statistical processes and tools to accomplish the goals. Increasingly, companies are also interested in data analytics to optimize the value gleaned from business and consumer-related data, and statistical analysis forms the core of such analytics. Statistical analysis uses specialized terminology, and the key terms at the end of this particular chapter are essential for understanding. To summarize a data set, such as financial measurements, you can use various measures to center. These measures provide an indication of a typical or average data value in a set. For example, you may calculate the average closing price of stock over a 3-month period to get a sense of the typical price of the stock over that time period. You should be able to calculate various measures of the average of a data set, such as a mean, median, mode, and geometric mean. The average of a data set is a way of describing location. The most widely used measures of center of data are the mean or average, median, and mode. The arithmetic mean is the most common measure of the average. To calculate the mean of a data set, add the data values and then divide by the number of data values. To determine the median of a data set, order the data from smallest to largest and find the middle value in the ordered data set. To find the mode of a data set, determine the most frequently occurring data value. The median is a better measure of the center of a data set as compared to the mean when outliers are present. The geometric mean is used to generate the average return of investment over time. The weighted mean is used when each data value is assigned a certain weighting, such as weighting of different stock purchases in a portfolio based on purchase price. The geometric mean provides a different approach for the center of a data set as compared to the arithmetic mean. For the arithmetic mean, calculate the sum of the data and divide by the number of data values. The geometric mean is calculated by multiplying all the individual values and then redistributing them in equal proportions such that the total product remains the same. To calculate the weighted mean, each data value is assigned a certain weighting. Create a table with data values in one column and the weights in the second column. Then create a third column in which each data value is multiplied by each weight on a row-by-row basis. The weighted mean is then calculated as the sum of the results from the third column divided by the sum of the weights. In addition to the measure of center, the measure of spread or variation in a data set is important. It's good practice to report both a measure of center and a measure of variation for a data set. In some data sets, the data values are concentrated close to the mean. In other data sets, the data values are more widely spread out. Measurements such as the standard deviation and variance are used to quantify this amount of variation in a data set. The standard deviation of a data set is a measure of how far the data values are from their mean. This provides a numerical measure of the overall amount of variation in a data set and can be used to determine whether a particular data value is close to or far from the mean. The standard deviation provides a measure of the overall variation in the data set. It's always positive or zero. It is small when the data values are all concentrated close to the mean, exhibiting little variation or spread. It is larger when the data values are more spread out from the mean, exhibiting more variation. Two different formulas for calculating standard deviation are included here. Which formula used depends on whether the data represents a sample or population. S is used to represent the sample standard deviation, and the notation sigma is used to represent the population standard deviation. We see the formulas here on the screen as well as their notations. Note that some technology like Excel is used for these calculations. Variance also provides a measure of the spread of data values. The variance of a data set measures the extent to which each data value differs from the mean. The more the individual data values differ from the mean, the larger the variance. Both the standard deviation and the variance provide similar information. In finance, variance can be used to determine the volatility of an investment and help guide financial decisions. For example, a more cautious investor might opt for investments with low volatility. Similar to standard deviation, the formula used to calculate variance also depends on whether the data is collected from a sample or a population. S squared is used to represent sample variance, and sigma squared is used to represent population variance. Calculating the variance and standard deviation of its data set by hand is tedious due to the complexity of the formulas. A financial calculator or Excel is recommended. There is a relationship between the standard deviation and variance for a data set. Once you calculate one of the values, you can directly calculate the other. Variance is the square of standard deviation, and standard deviation is the square root of the variance. If you know the standard deviation of a data set is 12.5, The variance can be squared by taking 12.5 squared to yield 156.25. If you know the value of the variance, you can determine the standard deviation by calculating the square root. For example, the variance is 31.36. The square root of 31.36 yields the standard deviation of 5.6. A disadvantage of using the variance is that the variance is measured in squared units, which are different from the units in the data set. If the data set consists of ages measured in years, then the variance will be measured in years squared, which is confusing. The standard deviation is measured in the same units as the original data set, and thus the standard deviation is used more often than the variance to measure the data set spread. Measures of position are used extensively in the finance industry. A mutual fund may claim its returns are in the top quartile with respect to fund performance as compared to other mutual funds in the same industry. A financial consultant may be interested to know her percentile for salary as compared to other employees. A z-score or z-value is a measure of the position of an entry in a data set. It represents the number of standard deviations by which a data value differs from the mean. In a certain year, the rates of return for various technology-focused mutual funds are examined, and suppose the mean is 7.8% with a standard deviation of 2.3%. A certain mutual fund publishes its rate of return as 12.4%. Based on this, the relative standing of this mutual fund compared to the other technology-focused mutual funds using a z-score measurement gives you the measurement in relation to the mean and standard deviation for the entire population. Common measures of locations are quartiles and percentiles. Quartiles are special percentiles. Q1 is the 25th percentile. The third quartile, Q3, is the 75th percentile. The median, or M, is both the second quartile and the 50th percentile. To calculate quartiles and percentiles, the data must be ordered from smallest to largest. Quartiles are divided into quarters, and percentiles are divided into hundredths. Percentiles are useful for comparing values. In finance, a mutual fund might report that the performance for the fund over the past year was in the 80th percentile of all mutual funds in their peer group. This indicates that the fund performed better than 80% of all the other funds in the peer group. This also indicates that 20% of the funds performed better than this particular fund. Quartiles are values that separate the data into quarters. Quartiles may or may not be part of the data. To find the quartile, first find the median, which is the second quartile. The first quartile, Q1, is the middle value or median of the lower half of the data. Q3 is the middle value or the median of the upper half of the data. IQR, or the interquartile range, is the number that indicates the spread of the middle half, or the middle 50% of the data. It's the difference between the third quartile, Q3, and the first quartile, Q1. Quartiles in the IQR can be used to flag possible outliers in the data set. An outlier is a data value that is significantly different from the other data values in the data set. To detect outliers, use quartiles in the IQR to calculate a lower and upper bound for outliers. Any data values below the lower bound or above the upper bound will be flagged as outliers. These data values should be further investigated to determine the nature of the outlier condition. Statistical distributions are used extensively in the finance industry. For example, many financial trends follow a normal distribution. A frequency distribution is a useful method to organize and summarize a data set. A frequency distribution provides a method to organize and summarize data. For example, one may be interested in the spread, center, and shape of the dataset's distribution. When a dataset has many data values, it can be difficult to see patterns and come to conclusions about important characteristics of the data. A frequency distribution allows you to organize and tabulate the data in a summarized way and create graphs to help facilitate interpretation of the dataset. To create a basic frequency distribution, set up a table with 3 columns. The first column will show the intervals for the data. The second column will show the frequency of the data values, or the count of how many data values fall within each interval. A third column can be added to include the relative frequency for each row, which is calculated by taking the frequency for that row and dividing it by the sum of all the frequencies in the table. The normal probability density function, which is continuous, is the most important. The normal distribution is applicable when the frequency of data values decreases when each class is above and below the mean. The normal distribution can be applied to many examples from finance, including average returns from mutual funds over a certain time period, portfolio values, and others. The normal distribution has 2 parameters, the mean and standard deviation. The mean is represented by mu. The variable x represents the quantity being measured whose data values have a normal distribution. To determine probabilities associated with the normal distribution, you find specific areas under the normal curve. Note that the normal distribution is also known as the bell curve due to its shape. The exponential distribution is often concerned with the amount of time until some specific event occurs. A finance professional may want to model the time to default on payments for company debt holders. This exponential distribution is one in which there are fewer large values and more small values. Marketing studies have shown that the amount of money customers spend in a store follows an exponential distribution. More people who spend small amounts of money and fewer people who spend large amounts of money. Exponential distributions are commonly used in calculations of product reliability or the length of time a product lasts. The random variable for the exponential distribution is continuous and often measures the passage of time, although it can be used in other applications. Probability distributions are used in finance to help calculate measurements such as the expected return portfolio or the portfolio weights in an investment. In many financial analyses, the weightings by asset category in a portfolio are a key index used to assess if the portfolio is meeting allocation metrics. For example, an investor approaching retirement age may wish to shift assets in a portfolio to more conservative and lower volatility investments. Weightings can be calculated in several different ways. For example, based on individual stocks in portfolio or on various sectors in portfolio. Weightings can also be calculated based on number of shares or the value of shares of a stock. To calculate a weighting in a portfolio based on value, take the value of the particular investment and divide it by the total value of the overall portfolio. A probability distribution is a mathematical function that assigns probabilities to various outcomes. You can assign a probability to the outcome of a certain stock, increasing in value or decreasing in value. One application of the probability distribution function is determining expected value. In many financial situations, we're interested in determining the expected value of the return of a particular investment or the expected return on the portfolio of multiple investments. The normal bell-shaped distribution can be utilized in many applications, including financial contexts. The normal distribution has two parameters, the mean and the standard deviation. When analyzing data sets that follow a normal distribution, probabilities can be calculated by finding areas under the normal curve. To find the probability the measurement is within a specific interval, compute the area under the normal curve corresponding to the interval of interest. Areas under the normal curve are available in tables, and Excel also provides a method to find these areas. The empirical rule is one method for determining areas under the normal curve that fall within a certain number of standard deviations of the mean. One standard deviation is 68% plus or minus one standard deviation, plus or minus two standard deviations is 95%, and plus or minus three standard deviations is virtually the entire distribution at approximately 99.7%. Graphing financial data is very helpful to interpret trends and formulate conclusions regarding data set. A financial advisor will graph indices such as the S&P 500 or Russell 2000 over time to detect trends and patterns. Univariate and bivariate data can be plotted, and the type of graph to be utilized is dependent on the type of data and intended data analysis. Data visualization refers to the use of graphical displays to summarize data to help to interpret patterns and trends in data. Univariate data refers to observations recorded for a single characteristic or attribute, like salaries or blood pressure measurements. When graphing univariate data, choose from among several types of graphs, like bar graphs, time series graphs, etc. Bivariate data refers to paired data, where each value of one variable is paired with the value of a second variable. The most effective type of graph to use for a certain data set will depend upon the data's nature and the purpose of the graph. A time series graph is typically used to show how measurement is changing over time and to identify patterns or trends over time. The most effective type of graph to use for a certain data set will depend on the nature of the data and the graph's purpose. A time series graph is typically used to show how measurement is changing over time and to identify patterns and trends over time. Bivariate data refers to paired data, where each value of one variable is paired with a value of a second variable. Typical examples of graphs for bivariate data include time series graphs and scatter plots. To construct a time series graph, you must look at both pieces of the paired data set. Start with a standard Cartesian coordinate system. Horizontal axis is used to plot the time increments, and the vertical axis is used to plot the values of the variable you're measuring. By doing this, you make each point on the graph correspond to a point in time and a measured quantity. The points on the graph are typically connected by straight lines in the order in which they occur. A scatter plot or diagram is a graphical display intended to show the relationship between two variables. The setup of the scatter plot is one that one variable is plotted on the horizontal axis and the other variable is plotted on the vertical axis. Each pair of data values is considered an XY point, and the various points are plotted on the diagram. A visual inspection of the plot is then made to detect any patterns or trends. Additional statistical analysis can be conducted to determine if there's a correlation or other statistically significant relationship between the two variables. Thanks for watching and listening. Be sure to like and subscribe.